Hi, everybody. Welcome back. Good evening, and hope you're all doing well. Had a great weekend. We got about 5-6 minutes, and then it'll be 5:30. So just get comfortable and ready to learn some stuff. Going to add a little bit more material on the topic of time. So that's the plan today. As usual, feel free to say hello or any type of comment you like in the chat. Hey Gary, see you there. Hope you're doing good. Hi Rachel, good to see you. Sorry about the confusion with our email the other day. I just was confused because I thought you had sent me the message just to check on a grade, but not to worry. I'm good. Yeah, doing well. It's kind of crazy times for the country in a weird way. So I'm following the news like I always do. But I feel okay about our future and everything. So yeah, I'm feeling well. Yeah. Stormy waters. But it's fine. I think we've been through probably worse, maybe. So we'll be okay. 4 minutes to go. Kind of slept on my shoulder a little weird last night, so it's a little bit sore back there. That's why I'm kind of massaging my own shoulder a little bit. Not too bad. Eddie? Peach? Cats are running around down there. Just out of the frame. Hi Haley, good to see you. Two, Eddie and Peach. So they're brother and sister, and they're now they're like almost 8 months or 7.5 months old. They were born on March 29th, so they're a lot of fun. Super cute. Hi Sierra, good to see you too. Okay, just another minute, and then we'll get going. It's your guys' last class of the day, probably, right? Or maybe somebody has a night class. Probably for most of you guys, this is it, I would assume. For me, it is. I have some earlier classes, but this is the last one for my Tuesday, Thursday schedule. Hi, Ronald. Cool, good to know. I know the last one sometimes feels like you've already been through so much in the day, but you know, it's also kind of nice to feel like as you're getting close to the finish line, you kind of get a little extra energy too. So, kind of pros and cons. All right, guys. So it's 5:30, so I'm going to go ahead and let us get back started. This is your only class with a Zoom call. What do you mean by that, Ronald? Do you mean without a Zoom call, or do you mean your other classes don't even meet? What is that? I would love to know. What do you mean? Oh, okay. So, and you're doing them all at Cal State Fullerton, right? I mean, I thought that it was a little bit more widespread. At least in our department, the chair really, advises us to hold the online lectures that are live in real time, synchronous. That's always my preference. I think that it makes it a little bit more like structured and more interactive. But yeah, the asynchronous is something that I know a lot of professors are offering, especially now. But I like to preserve as much as possible the time-honored traditions of students attend a meeting and we all know what time it is. But I feel like this, in a way, is it offers you the best of both worlds, because to those students that really are not able to be there or would prefer to just watch it later, they have that option since it's all posted online. Some professors may also want to reduce their workload a bit. I mean, if you're not always having to give lectures and you can just share links and have people read PowerPoints and stuff, then you're not as much engaged with the students. But I think it's important to have the human contact and not just to be like a officer or something like that. But all right, anyways, welcome back. So we are going to talk a little more about time. This is another lecture on that topic. Here's the author for today. Okay, so Ted Sider is an American philosopher who lived, well, he still lives, so he was born, in 1967, and he's still going strong. This is a paper that comes from a book he wrote in 2005 with Earl Coney, and the name of it in our textbook is just Time. So Ted Sider, his full name is Theodore Sider, but I know some philosophers that are friends with him and stuff, and he just goes by Ted just in his everyday life. So that's kind of what I'm used to. Ted Sider, and paper from 2005 just called Time. This builds on our discussion from the last meeting. Let me just quickly go over some of the major points that we discussed, because we covered Einstein and some of his work on relativity on the Thursday meeting last week. So first of all, Albert Einstein says this: suppose that there were two strikes of lightning that both happened on different points of a railway. Say that there's one on the left, we'll call it A, another one on the right, and that's B. And then he asks the reader, suppose that those happen simultaneously, tell me what does that actually mean by definition, that they happen simultaneously? And he says it's not so easy to actually define the concept as you might have thought at first, because any attempt to do so kind of runs up against the circular definition that you might say, oh, it means they happened at the same time or at once or whatever. So he says, here's a better way of thinking about it. We need to be able to give a test that could test the question if they're simultaneous or not. So wow, how could this test be performed? All right. He says, measure the distance between the two positions A and B, designate the midpoint M, and place one observer there who stands still at M. Now, if this observer is at M, that means he's equidistant from A and from B. Since he's the same distance away from both, if the two light signals reach him at the same time, so he sees them in the same visual perception, then if we assume the speed of light is constant and fixed, this means that the two light rays reached M at the same time, traveled the same distance, and moved at the same speed, so that means they must have originated from the 2 points at the same time also, meaning that they would be simultaneous relative to that condition of observation, the motionless observer who stands poised at M. But if we have a second observer who's being carried through the scene on the moving train with constant velocity v, and they strike the midpoint M prime, at the moment that the other stationary observer does their observation, then the man who's on the train will not see A and B happening simultaneously, because given his state of motion and the direction of his travel, he's moving now farther away from the midpoint where he was equidistant between A and B. So now he is closer to the point B than he was to the point A, meaning that the asymmetrical distance gives the first lightning strike that he will perceive as B, and then subsequent to that A. So the two lightning strikes A and B cannot be stated to be objectively simultaneous or non-simultaneous. To one observer in this explanation they are, and to another they aren't. And neither one is like the correct observer. All we can say is that the order of the events is relative to the observer given their state of motion and the observed events. And then after that, we extended these results a little further by talking about the time dilation concept and how light clocks can explain this, and then also the idea of the twins paradox. Now, Rachel, I see your comment. You say, I'm not sure if it's your Wi-Fi, but you can barely see me. Is any other student here having this problem? Am I visible to everyone? Let me know in the comments if you can hear me and if you can see me. That would be helpful. Just let me know. Same here, Danny. So what is, can you describe? It's just a little bit laggy, but you can still see me. The screen you say is blurry. Okay. Pixelated. Is it improving at all, or is it not? It's blurry. Okay. Not to worry, guys. We'll get a quick fix going. So give me just 1 minute, and if this is not improving, I have a solution ready. Okay, just give me a second. I'm opening another window, and this will just take me a moment. All right. Sorry for the delay. I have to do the dual authentication thing when I get onto the portal, CSUF portal. Okay, 1 second. Okay. It does say Ted Sider, yes. The man's name, Ted Sider, 1967. 2005 was the date of publication, and the article is called Time. Okay, so any update on the current status of how I look to you guys? Is it still blurry? Just one more question about that. Let me know. Is it improved, not improved, or just the same? Still pretty blurry? Okay, not to worry. Well, here you go. So you see this? There's a link. Click the link, please, and we will just do dual platform. This video will remain archived on the YouTube channel that I have, so you can please go back to it later. I think the playback will not be so blurry. It is simply the live recording of it that is blurry. So when this happens, and it sometimes can occur due to, I guess, just high traffic on the website or the bandwidth that everyone's using on my Wi-Fi router. So let's go to this Zoom meeting, and then you can use that to view and hear me speak. Okay, so all right, there's the chat to the right. How about now? Can anyone please in the Zoom chat type in and tell me how your quality is right now? You may have to mute your other window if you still have the YouTube going or whatever, but now we're all right? Okay, guys. It's just one of those things. We're navigating a, online environment. So when these things happen, I'm always ready with a backup plan. Okay, guys, so anybody who is at the YouTube meeting, hopefully you've switched over. Now we're gonna just continue and resume the meeting here on this platform, and the recording will remain on YouTube. Okay, so Ted Sider, 2005 Time. The author, Ted Sider, has this overall goal behind his paper. He just wants to try and explain to us what are some of the basic philosophical puzzles and problems that arise when you start to think about the concept of time. He says it's sort of difficult to question the nature of time because we usually just take it as a given and we take it for granted. It's like the air that you breathe. You know, you don't think much about inhaling and exhaling. It's an autonomic process of your nervous system. But then when you do think about it, it's like, wow, I need to kind of pay attention to my breathing. Am I breathing too shallow, too deep, or whatever? If you're a fish and you're, you know, in the ocean, of course you're not going to be that intelligent if you're a fish. But if a fish had intelligence, it might not ever stop to think, hey, what is water though? You know, it's just surrounded by it and it lives with it. So it doesn't have a moment to step back and ask questions about it. We are kind of like those fish, and time is kind of like the water. We deal with time. We're all aware of time. We're always keeping appointments and following a schedule, but we don't usually step back and say, hey, what is it though? What is time itself? The thing is, he says we should ask those difficult questions, analyze it beneath the surface level of depth, because once you start to do that, you'll realize that the idea, the ordinary idea of time that we have stops making coherent sense, or it starts to break down. Now, here is what he thinks is really puzzling. The first thing he points out what is so strange about time. So, time is puzzling because people say that time moves. Okay, but what does it mean to say that time moves? And that is very hard to explain. So one thing that seems to be built into our ordinary way of thinking about time is that when you ask people what is their sense of it, they say, well, it's something that moves. And there's a lot of everyday common phrases or expressions that give voice to that idea that time is something that moves. For example, what are some common sayings, if you've ever heard any, which include the idea that time is somehow in motion, that it's a thing which is moving? Any phrases? Okay, good, Brooklyn. Time flies. That's one of them. Flight is physical flight through the air. So if time flies, we're saying, like, metaphorically, something that moves around. That's not the only one either. Time flies. What's another kind of phrase that it has the same idea? Time moves in some sense. Like what? We say time flies. I have a few more on my mind. Time holds still. Yeah, like, oh, time stood still for a moment. People also sometimes say time waits for no one. Sometimes people say, well, it's been ages isn't exactly the one that I'm looking for, Danny, because I'm trying to give statements here that express time moving, like time is marching on, time is passing by, time is going so fast, oh no, it's going really slow. Just talking about it's been a long time or it's been ages, no, guys, that's not the idea, because that doesn't, well, long, I guess you can say long in terms of like physical length, sure, but movement isn't the same thing as something with length. Movement means that something moves, like it passes through stuff. So you can say time passes, time marches on, you know, time flies, or whatever the case may be. Oh, time is moving so slow, it's like so boring. So all these common phrases express the idea that time is something flowing, moving, like it's a flowing river, and we're just caught up in the flow of that stream. But ask yourself, what does it really mean to say that time moves? The reason that this is something that is really weird and puzzling is because to define movement itself, we actually have to make a reference to time, even to define motion. So what does it mean to say that time moves? This is, you know, puzzling because time is needed to define motion itself. Let me explain that. So let's think about what it means for something to just even move through space. Okay, so like here is this expo marker. Right there it is standing on the table. This is point A. Let's say over here where this eraser is point B. What I'm now going to do is I'm just going to move this marker from point A to point B. So here we go. Wow, there we go, it happened. So you just saw that. You saw the marker move. let's go into the details. What does it mean that it moved? Well, for it to move, it had to be at different places. At what? It had to move. If it moved, this does mean that it was at different places at, can you finish that sentence? At different times, exactly. So what's the definition of an object going through space and moving? It means that it has to change its position over time. Okay, because look, if this object, this marker, stays in one place for all time, then that means it's motionless, it's at rest. When it's not at rest, when it's moving through space, that means it's in different positions, not the same one, but different positions at different times. Now, if something was at different positions all at the same time, that's not movement, that's just a thing that's like scattered apart, like a, you know, like a bunch of matches that you just allow to just spread apart. But something which is moving is at different places. The one object is at different places at different times. So if time moves, plug in the word time to this definition of motion. That would mean that time moves by being at different places, what? At different times. But now we're going in a circle, because now we're trying to define the movement of time with reference to the concept of time itself. But that's a circular definition. You can't define something by means of itself. That's like a cat or dog chasing its tail, right? We need a non-circular analysis of what it means for time to move. So again, if we just say time moves because it's in different places at different times, what are we saying? We're defining time in terms of time, which does not really make any kind of clear sense. So that's a puzzle right there. What do we say or mean by the statement that time moves? Well, let me show you a graph really quick, which will explain very clearly this point that movement, even through space, requires for an object to be at different places at different times. So this is a graph that's also in the book in his article on page 458. So if you ever want to look at it there, you'll see it there. But here I'm going to draw it on the board. So what we're going to show are four horizontal lines, okay? And this is going to be a graph which basically depicts the movement of a train from an origin in Boston to its final destination in Washington, D.C. So underneath each of the four horizontal lines, I'm going to write four place names for four cities. So we've got Boston, New York City, Philadelphia, and then finally Washington, D.C. So we just reproduce that in these four spaces under each line of the graph. Okay, now over here on this axis, we write four time coordinates. So that's lowercase t with a subscript. So it's like t1, t sub 2, t sub 3, t sub 4. In other words, time 1, subsequent time, time 2, further later time, time 3, fourth later time, time 4. Okay, so this train, let's say that it starts off and it's in Boston. That's at the initial time as it begins its journey. At a later time, because 2 is like higher in the number series than 1, subsequent to 1, later, it's in New York. Later on, third time later, it's in Philadelphia. And finally, at the fourth time, it arrives to its destination, DC, Washington, DC. So look here, just as kind of like really reiterating the point I was making before. What does it mean that this train has traveled from Boston to Washington, that it moved from point A to point B? Well, for it to move from this place to this place, it has to be in different places at different times. What if this graph looked a little different? What if the graph showed that the train is in Boston, 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 Boston throughout all of those times? If that was the way the graph was shown, then does that describe or depict a moving train? No. That would be showing a train that stayed in the station all day. It stayed in one place all the time. That's not moving. So moving means, yeah, you're in different places at different times. That's moving through space. But again, we've reached a circularity in the definition of time, because when the person says time moves, if the definition of movement is being in different places at different times, then moving time would mean that time is in different places at different times, which makes no kind of coherent sense. Okay, so he says next, Ted Sider says after this opening salvo of reasoning, he says, well, maybe another way to explain the movement of time is to say what it means is that the present moment is moving. Okay, maybe the movement of time is best understood by saying that the present moment is what keeps moving around. So what is the present? The present is right now. So right now, the present moment is happening, and it's 5:49 p.m. on November the 10th of 2020. But this present moment is only for a split second. The present moment keeps moving. So like later on tonight, 8 p.m. will be the present moment. Right now, it isn't. 8 p.m. on November 10th is the future, speaking right now. But when it happens and when that time gets here, then that'll be the present. And it continues, you know, then later on after that, tomorrow morning will be the present. Or let's look backwards. When you woke up this morning, remember that? You're like, oh God, another day. No. But anyway, you opened your eyes, and at that point, whatever the time was, 9:30, 10 a.m., I don't know when you wake up, that was the present moment. And this meeting that we're having now was in the future, okay? But it's happening now. So the present moment, you can say, is the thing that's moving and changing its position. It just doesn't stay put. It moves from one point to another. And so this is maybe the best idea of explaining the movement of time. Sounds like a decent explanation, right? But what Ted Sider is going to show is that actually, no, that still is problematic, and it still involves circular definition. So here, let me give you another graph. And this is also placed in the book on page 459. This is going to try and be a graph that shows what it could possibly mean to say that the present moment moves, and that's the explanation of time moving. So we got, again, these four horizontal lines. And in the four positions underneath it are 4 times of day. So here, 12 p.m., noon, then 3, 6 p.m., and then 9 p.m. Okay. So maybe this graph now can show us what is the interpretation of time moving. It's the present moment that's moving. So like in a given day, the present moment moves and changes its location as seen in this graph. So suppose that this was today or whenever. You're up in the morning and it's noon, it's like lunchtime, and then at that point, this is happening, it's noon, and that's present. Later on, subsequent later time, 3 p.m. is the present moment. And then later, as we get to like evening hours, 6 p.m., pretty much coming close to where we're at now, then that's the present moment. And then even later in the day, it is 9 p.m., closer to bedtime, and that's the present moment. So maybe this is our best explanation of what it means to say time moves. But what Sider says now is that actually, no, sorry, but there's still a problem here. There's a little bit of a problem with this graph. Now, I don't know if you'll be able to sort of spot it, but maybe you will. Let me ask you, can you see something about this graph that is undefined, that leaves us asking still questions? Well, what does that point in the graph actually mean? Or what does that thing that is shown on this board mean? There's a problem. What's wrong with this graph? If you can see it. Even if you just have a wild guess, that's fine. But let's see if you have any thoughts. Can you tell me? What is the present? Well, that's a very good and insightful response. Yeah, you could mention that, like what is the present? But hold that thought. There's actually a slightly different problematic feature of the graph that he's pointing us to here. There's something that's on this graph that isn't defined. What thing could it be, or things? Time. Okay, good, Rachel. Yeah, well, I was mentioning these for indicators here. What is T1, T2, T3, and T4? These look like they are 4 points in time, right? But that means that we're just saying that this present moment is moving because it's in these different positions at different times. Now we have a new question. Well, what are these 4 things, and how are they organized in the linear sequence 1, 2, 3, 4? For these 4 time points to have an ordering, you'd assume, well, they have to be located within an even bigger graph, where they are ordered because they are placed in a context where there's a third order sort of time. Okay, so it's basically leading us to an infinite regress. If the present moment is defined as moving with respect to these 4 temporal points, then these also have to be ordered according to a broader definition of time, a third order sort of time. And if that has a sort of linear ordering, then that requires us to place that in the context of an even bigger graph where there's a 4th order sort of time. And it goes on and on and on to infinity. So we're still in this circular definition of time, or the movement rather of time. That time moves by moving with respect to certain time points that are placed in a sequence that goes in a linear direction from 1 to 4. But how can these 4 time points be organized in that sequence unless they themselves occur in a given order with respect to an even larger definition of time? So it looks like trying to explain how time moves has just tied us all up in knots and left us with no coherent explanation. So the next thing that Ted Sider says is this: let's go in a different direction then, and let's just give up basically. Let's say, never mind, time actually doesn't move. And that's something that we can say because that is implied by the space-time theory of Einstein, all right? So according to Einstein's theory of space-time, all the moments of space-time are equally real and they all exist. It's not just the present moment that exists, but it's all the moments of the past and the entire future. They're all just as real as each other, and they all exist in reality in space-time, in the whole space-time fabric. That is an implication of Einstein's relativity theory, because if you go back to the lightning example, what's the order of the 2 lightning strikes? Well, there's no objective fact about it. According to one observer, A happens and then B. To another observer, B happens, then A. To a third possible observer, they're happening at the same time. So if all 3 sequences are possible, given some possible observer, that means there's no fact about which one is the thing that exists before the other. Thus, all of the moments have to be equally accessible to reality, and they must all exist. If that's the case, then time and space are linked, and there's no movement to time at all. It just sits there containing all the events jointly with space. This is sometimes by metaphysicians called the block universe theory or view. It's the idea that the entire universe is kind of like a block with everything that ever happens already fully set out in it, like as though it's a completed painting with every event already there. Everything that you believe to be part of your future is an existing fact in the space-time universe, as well as everything in the present and past. So if we accept this view, we no longer have the difficult job of trying to explain how time moves, because we just say, never mind, it actually doesn't. But now, if we embrace the space-time theory, we get rid of one problem, but now we have some other issues. If we no longer have to define how time moves, that's great. But what are we supposed to think about the nature of objects, and even of ourselves, according to the space-time theory? So that's the next thing to discuss. What is the nature and understanding of objects if space-time theory is correct? Well, to illustrate that, we have to draw what is called a space-time diagram, okay? And there's one of these that is shown in the book on page 460. So I'm going to try and draw one for you here. Okay, now, let us say that this is the y-axis on a typical graph, and this is the x-axis. This horizontal line that's running through the intersection of them, let's call that the t-axis or dimension. That t stands for time, okay? Now, a real space-time diagram would have 4 dimensions. It would have 3 spatial dimensions, so height, width, and depth. And then there would be the 4th temporal dimension running through the intersection of the 3 spatial dimensions. So to actually draw like an accurate rendering of such a graph, I couldn't place it on a 2-dimensional board surface. It would have to be like a 3-dimensional pop-up cardboard cutout or something where you'd see a line running through the 3 spatial dimensions. But anyway, you have to kind of use your creativity of the mind to just imagine that this is our typical horizontal y-axis, this is our vertical x-axis, and this is running at a tangent line through the intersection of the 2 other planes, okay? Now, X and Y are the spatial dimensions, and this is the temporal dimension, the time dimension. So to graph the existence of an object in this space-time diagram, we simply designate the point in time where the object starts existing. So suppose this is one of you that I'm going to graph right here. So it's the year 2020. This is intro to philosophy. Many of you, I guess, are freshmen in college. So an average age is probably in many cases around 18. So let's just suppose here's a person who was born in like 2002, okay? Maybe like you were, okay? And let's say that that person lives a very good, healthy, long life, like I hope all of you do, and you live 100 years or something, until 2102. Okay, so that's the end point on the graph of the time dimension. So here now I'll show you the graph that captures the full existence of this person's life in space-time. Okay, so we see this graph. It's a series of stick figure shapes to show like a human form. And why is it extended through this t-axis? Well, okay, let me ask these as questions rather than just saying it as statements. Why do you think, anybody watching this, why do you think that I've drawn the human figure a little bit shorter along the x-axis here at the beginning of the timeline, and later on along the timeline, there's greater vertical height along the x-axis? Why do you think that at the beginning of the timeline where 2002 begins, the human shape is shrunk down on the x-axis? Okay, good. Good, Gary and Ronald. It is because of the size, physically. You know, a human being born, as you all know, starts off quite small, a little baby, as we all started off. But, you know, as time goes on, you grow a little and you get bigger. So that's shown on the graph by the stages of the human development getting bigger along the spatial dimensions, all right? Now, another question. Why is it that you think that we have this extension along the t-axis? What is that showing us? Why is there this streak running along the t-axis with all those human figures? So we've talked about the extension along the x-axis. What is the extension along the t-axis supposed to show? Extension on the x-axis shows vertical height in space. Extension along the t-axis shows something else on the graph, and that is showing us what about this object or human? That what? What does that indicate or depict? What is it meant to represent on the graph? Time, okay, so it's showing the duration of the human's existence in time, and it's cut here, and it discontinues at that point because the person dies, I guess, it ceases to exist. So this space-time diagram shows us a graph of an individual's existence across both space and time. It extends and stretches along the t-axis to show the length of time it exists, and it extends along the other axes to depict the spatial size that it has at any given point along the timeline. Now, if there was an object that existed for just an instant, like an instant, and then it just annihilated, like a particle of antimatter or something that just erupts into the universe and it instantly is annihilated, then in that case, it would not have any extension along the t-axis. It would just be like an individual point on that line. But thankfully for me and you, we exist for some span of time, not as long as perhaps, you know, trees or planets, or, you know, I don't know, there's turtles and stuff that I guess have longer lives than us, but at any rate, we live for some good amount of time, and that's why there's a little bit more extension along that t-axis. Okay, so on these four-dimensional graphs, these space-time diagrams, an object has got both spatial parts and what are called temporal parts. So now this is an important definition to add to our notes. Temporal part. A temporal part of an object is just the whole object at a single moment of time. Okay, so an object at a single moment of time. So Spatial parts of an object are just the physical parts of it that occupy space. So like for a human, for example, your spatial parts would be like your different body parts, hands, head, torso, feet, legs, etc. That would be your spatial parts. I have spatial parts. They're taking up the space right here in this chair, occupying the space. But according to the space-time theory, you also have what are called temporal parts. And a temporal part is the whole object, but at a single moment of time. And these temporal parts are stretched out like an accordion through the whole time sequence that you exist. And there is one at each new moment of time as the object endures over that timeline. Okay, so let's make sure that you understand what I'm now saying. I'm going to ask you a question. Just tell me if you can think about and answer this. We all take pictures all the time, right? So you snap pictures and stuff. If you have a pic of yourself, or anyone has a picture of you, how many of your temporal parts are shown in the photo? I'm talking about, a good clear photo of you. How many temporal parts of you are represented in that photo? Let's see if you can think about that, and you'll just give me a correct answer. What number of parts? It's one. Good. Correct. Now tell me, since you said one, and I'm telling you that's right, what is your intuition of why that's your answer? Why is it that there's only one temporal part of you shown in a photo? That's correct. It's one unit, yes, but let's expand on this. Because that is only, there's only one of you in the photo. I know that. It's one person, but no, guys. Why is it that it's just one temporal part of the person? One individual each time. We're getting close with the way you're putting it there, Gary. It's because the photo only shows you for how long? It's a still photo. Come on. So what's shown in the picture is you for what duration of time? Is it you like over 5 seconds? Is it you over 30 seconds? It's not a video. We're talking about a still photo. So in that case, it's a single snapshot of you. I mean, you say within a second, but if you're using like an old camera or something, it should be like instantaneous, right? So otherwise you'd see blur, you'd see motion blur and stuff in the photo. I'm not talking about that kind of photo. I'm talking about like a clear shot where it just shows you smiling or something in the picture. In that case, it's a single instant. It's one moment of your existence, right? So that's one of your temporal parts, just one, because there's a different one for each moment. Each different moment that the whole object continues to exist is a different temporal part. And the claim of the space-time theory is that all your temporal parts exist, not just the one that's watching this right now, not just the present temporal part, but all of your future stages, all located out ahead of you on your own timeline. They're all out there and they're all real. They're just as real as this moment. And all of the past temporal parts, they're just as real too as the present, and they haven't gone anywhere. They still exist in the universe. So this is a reversal of a common sense way that a lot of us think, that the present moment is the only thing that's real. The past is just gone, doesn't exist anymore. The future hasn't happened yet, and there's nothing about it that's definite. It could be anything. On the space-time theory, no. Everything is locked in, all the moments, present, past, future, they all exist, and for as long as you exist, there's a temporal part of you at each different moment that you do. So let me ask you another, this is kind of a trick question, so just be a little bit careful how you answer. But let's say you have a short video of you, like a little TikTok or whatever you guys are doing, and let's say it's like 5 seconds long. How many temporal parts of you are in that short video? Keep in mind, I'm sort of saying it's a trick question because it's not going to be too easy to give a real number, but you can give some kind of answer. How many temporal parts of you do you think would be in like a short video? Brooklyn, you say a couple, but I think you're underestimating the possibility of breaking time down into moments. And Ashkan, you're maybe going too far in the other direction, because if you say infinite, it's not like there's an infinite number of time intervals in that short span, because if there was, then you could never exhaust that infinite number of points in time and it would be an infinite duration. Now, you say, Rachel, 5. Also not quite correct, because you maybe heard that I said 5 seconds and you're like, okay, well, 5 seconds, 5 moments, but no. How many moments are there in 5 seconds? I mean, if you watch sports, you know that a lot of things can happen even in 1 second. Okay, so think about a clock that can record time way, way, way down to the nanosecond. I mean, even in 1 second, we could subdivide it into half seconds, quarter seconds, milliseconds, and break it down even further and further. You're saying it's relative. Well, here's the right answer. There are just as many temporal parts of you in the video as there are what in the video? As there are what in the video? There's just as many of the temporal parts as however many of these there are in the video. Well, again, it's not seconds, guys, because seconds is an arbitrary measurement of time. Do you understand that? Like, if we wanted to, we could have said every minute has 120 units and they're half a second long. And we could have just called the half second the unit and say there's 120 bleckens, and that's what it is for a minute to exist. So you really got to think about that. I mean, the unit of time, 1 second, is an arbitrary unit. It could have been double, it could have been half. But okay, good, Andrea. There would be as many of the temporal parts of you in the video as there are moments in the video. Now, how many moments are there in a short video? This is something that is impossible, perhaps, for us to give a precise number, but it will be a huge number because, you know, even in a short interval span of time, a second or so, you can cut that down into tenths of a second, hundredths of a second, and further and further. So you know how like a camera has a high frame rate if it's a very good camera? This would be like God's camera, like not infinite, but like the maximum frame rate possible in the physical universe. So for each of these moments, there's a different temporal part of you. Now, it's not infinite though, because as I was saying, if there was an infinite number of moments, even in a short span of time, then time couldn't pass because it would take an infinity of the durations to even surpass that short interval. What I think is the proper answer is that there's a minimum spatial extension and there's a minimum temporal extension. In physics, they call the minimum physical size the Planck length, named after Max Planck, the famous 20 is. That's the least unit, and there's a different temporal part of you for each one of those. I don't know if anyone's ever heard this film, Donnie Darko. It's a great film from the year 2000. I think it's enjoyed a little, I don't know why, renaissance of popularity lately. But it deals with some time travel concepts. It's a little bit of an art house film, so some parts of it are kind of obscure. But there are some scenes where out of the chest of Mr. Darko, you see like a kind of a worm-like streak protrude, and it's showing the track of his motion that he will follow as he gets up out of his chair and walks around. And it's like a trail that also you can see has followed him to where he's now positioned. So imagine that throughout your whole life, as you move, there's like a trail. And if we could see time and space outside of the one present moment that you are in, then we would sort of see like accordion-like stretched out space-time worm. Each cross-section of that would be like a moment and one of your temporal parts. Sometimes metaphysicians use the language time slice. Like a time slice would be one vertical cross-section in the sequence of events in your life, like as shown in a still photo, okay? So that's the understanding of objects that is given to us by the space-time theory. So we're in the position now to say, we're no longer burdened with the difficulty of trying to say how time moves. Never mind, it doesn't. It just sits there and contains all the events of space-time together with space. But if that's what we're saying is true, and it seems there's actually considerable, physical proof of that because Einstein's theories have been empirically verified, that would mean that we are space-time objects, and we do have these temporal parts. The temporal parts are claimed to be just as real as your physical parts are. So you look at your left hand right now, and it's real. Well, you, like in the year 2021, getting the coronavirus vaccine, that's relative to you now in your future, but it's a real event if it does happen in your timeline, even before you will witness it. So in a way, we're destined to do these movements. Yes, Ronald, that would be true. If this theory is correct, that means that you're really just an observer on the events of your life, and the free will that you think you have to like take decisions and take things in one direction and not another would simply be an illusion. Yeah. Let me ask another question as we're going over this topic of temporal parts, because it's pretty key to the lesson. I'm just testing your understanding, okay? So how many temporal parts of you are in this chair that you're in right now? I don't know if you're in a chair, but wherever you're at, how many temporal parts are there now as I'm asking this question? One, good. Now, what about now? Is it the same temporal part now as the one that I just mentioned? Or is it a different one? Say same or different? The temporal part now in your chair. It is different. Why is it a different one? Because it's a different moment, okay? So with each different moment, there's a different one of your temporal parts. Another question. So if this theory is to be accepted, would it mean, are you fully present watching this lecture right now? Are you fully there or no? Are you 100% present as you watch this, or are you not? What do you think would be the answer given by this theory? Well, you're saying yes, but the answer according to the theory is no. Because as you watch this lecture, what is watching this lecture? The whole thing? No, it's just what? What do you think is my response here? Well, it's a temporal part of you that's watching this lecture. Now, who is the whole person, or what is the whole person? The whole person that you are is the entire series of temporal parts extended throughout your entire timeline. And so if this theory is true, you're actually never at a given point in time fully present. Only some of your temporal parts are there. So like this lecture occupies a little stretch along your timeline. And the temporal parts that are in that stretch of time, they're the ones that are seeing this lecture. But the parts of you out ahead of your graduation and before you ever became a student here, they're not watching this lecture. So some of your temporal parts are involved watching this, yes. Are you the sum of all of your temporal parts? Right, that would be the right term instead of movements. You are the sum aggregate total of all the temporal parts on the full graph. That's what you are. You're the space-time worm stretched out through all of these dimensions of space and time. But in a single moment, part of you is there. But there's future and past parts that are left out from this lecture. Okay? Just giving you guys the full understanding of this. And so, just reading a bit from the book on it. So a complicated graph represents time alongside two spatial dimensions. It would be nice to represent all three spatial dimensions, but that would require a four-dimensional graph and a three-dimensional book. These more complicated graphs are called space-time diagrams. They can be used to represent all of history. Everything that has ever happened or will ever happen can be placed on the diagram somewhere. And so in their graph, they show a dinosaur existing way back in the Jurassic period, and then they show like a human being existing closer to our current day. They mentioned about the temporal parts. It says, in addition to the dinosaur and the person themselves, some of their temporal parts are also represented in the diagram. A temporal part of an object at a time is a temporal cross-section of that object. It is that object at that time. That temporal part is the same spatial size as the person, but not the same temporal size. Okay. Now, some people would reject the idea of time-space theory, but this is what Sider believes is the best theory that we currently have. It's the most well-supported by empirical evidence. And as weird as it may sound, and as counterintuitive as it may sound, there's considerable, actual evidence to confirm it. So the next thing he wants to do is explain this. If we're going to embrace the space-time theory, then we have to start to reconsider the way we think about time, and we have to start seeing it as having a lot more in common with space than we normally think. Okay, so the space-time theory means that space and time are not separate, but they're linked together in one kind of common tapestry. They're woven together as one structure, space-time, which means that time is considerably more like space than the everyday understanding of it would imply. So here he mentions three similarities between space and time according to the space-time theory. Okay. Okay, so one of the similarities is in terms, he says, in terms of reality. Okay, and what he means by that is that objects which are far away in space are just as real as objects which are present in space, and the same is true of time. Okay. Okay, so in terms of reality, objects that are far away in space are just as real as objects that are present in space. And the same is true of events in time. Okay, so let me explain this by means of a quick example. Can you guys see this marker? I think you can. Can we agree that this expo marker is something that is real? That this is just something real? That's all I'm asking. Is it a real thing? Sure it is. Okay, well, suppose I take this marker and I place it on a rocket. Well, I want to take it actually slower because the rocket's a little bit further down in this explanation or example. This whole discussion was easier when we were all in one classroom because I could say, hey guys, we're all here, you see the marker. What if I walk outside the room and you guys stay in here? And I take the marker into the hallway. And then I ask the students, would it still exist? You know, and of course you understand the answer, right? It's not like it's gotta be in your face to be real, and then as soon as it's outside your field of vision, oh no, it's no longer something that's real. Only a little baby that doesn't understand that objects remain permanent when they're outside of their vision would think that, okay? So you know very well that, I don't know, take your computer, that's a better example. It's right in front of you, so you know it exists. But what if the computer that you're now watching this on was taken a football field away from you, and you stay put? Would it still exist even though now it's a football field away? Sure. It doesn't mean removing from space causes it to like stop existing. Like there's a little force field around you, and if you take things 100 feet away from there, they just cease to exist. So if it's an inch away, it's real. If it's 10 feet away, it's still real. What if I take that marker, computer, whatever, and I place it on a rocket ship to the moon, okay? And I just drop it off down on the surface of the moon, but you're back on Earth. Now you guys are very far apart. Would it still exist and would it still be real when it's that far away from you? That's my question now. What do you think? I'm setting you up to just hit a home run. So would it still be real? Yes, it would be, okay? And you get the pattern, right? There's no distance far enough away where it would just cease to exist. It might get farther from you, but it's not like things are only real when they're close to you in space. If we took the same object and we put it on a Voyager space shuttle and we took it into interstellar space, far, far, far away from you, it's still going to be real, whether it's close or far. The spatial distance doesn't change its reality. Okay, now the same point then is claimed by this theory to be true of events in time. Okay, so right now, this is the present moment. We're all having a nice lecture for this philosophy class as you guys are taking it. So this is certainly a real moment. But what about the election of 2024, not the 2020 election? Hopefully that's over by then, but in 2024, given that we have an election at that future time, that's a farther away moment than this time is, right? That's 4 years time-wise away. But even so, that's real. That moment is just as real as this lecture that you're experiencing right now. So like you getting married, having kids, having grandkids, starting a business, graduating, all that stuff in your future is real. Not just the present, but all the distant times far away in the future and the past. Now, when we talk about time, we sometimes employ a spatial metaphor. Like we say, hey, remember back then when I was a kid? Back then, like behind me, like spatially behind me. Or sometimes we say, I'm looking forward to this election being over, or like, you know, I can't wait to get there when we're past this. Like as if it's a journey and we're making movement, like I'm looking forward on a path to some place I'll be as I move along the path. So we sometimes do talk about time as it's located at some distance from us, almost spatially. Like I can't see that far into the future. Sometimes people say like it's far away as though it was a spatial divide from you. Well, the point here, according to this theory, is don't think that the present moment's the only real moment. The past and future at any distance away from the present are just as real as this is. And it's much like space. In space, objects continue to exist at any divide or remove from you. And the same is true of moments that are far away from the present. Okay, so that's one of the three similarities between time and space, according to this theory. The second one is in terms of parts, and that's the temporal parts versus spatial parts. So okay, and the explanation of this one is that objects occupy space by having spatial parts, right? And likewise, objects occupy time or endure through time by having temporal parts. Okay, so another similarity between space and time, according to this theory, is that both are formed by parts. So objects take up space by having spatial parts. Like I take up this chair because I have, this mass and volume and shape because I have the body parts. And it's not just human bodies either, by the way, that I hope is clear. This table has spatial parts, right? It has like the legs, it has the tabletop, and so on. This marker has different parts. It has like the cap, the main tube where the ink is, and so forth. So spatial parts are what allow an object to take up some space. But the temporal parts are also parts the object has, and that's what accounts for its existence throughout time. Okay, and again, the author insists on a correct understanding that according to this stage of you getting the coronavirus vaccine, hopefully if it comes out next year or whenever, if that ends up happening or if that's part of your timeline, then that event is just as much real as your left hand is in terms of having body parts. Okay, so another similarity is in terms of parts. And then the third similarity that he mentions here is in terms of the words here and now. Okay, and what he means by this point is that both of those are similar because they're relative terms. And that means that their meaning depends on the context of the speaker. Okay, so both are relative terms. Their meaning is relative, so their meaning depends on the context of the speaker. Okay, relative terms, depends on the context. So let me try and explain that point now. Tell me if you can, so it's a trick question, but I'm asking you this funny question. Where is here located? Where could I find somewhere called here? Just where is here at? Can you tell me that? Where is here? It does depend where you're at. Okay, good. So if I say here we voted for Biden, and then someone in Alabama is like, here we voted for Trump. It seems like we're contradicting each other because I'm saying, no, here we voted for Biden, and he says, no, here we voted for Trump. Well, where is here? Here depends. When I say here, it depends where I am when I'm speaking. So as I'm speaking, I'm currently in Long Beach, California. And so if I say here, Biden was the winner, that's true because my word here refers to the spatial region around me when I say the word here. But a person in Alabama who says over here, Trump won, they're not referring to California with the word here because where they are at is a different place in space. And so they are using that word, but in a different part of space. If I say, here the governor is Gavin Newsom, and someone in New York says here the governor is Andrew Cuomo, we're not saying contradictory statements because the word here doesn't refer to the same place when I'm saying it on the West Coast and when another person's saying it on the East Coast. Okay, so it's not like when you open up a globe or you look on a map that you're going to find some position on it that says here. Anywhere could be here relative to a given speech act. Okay, so it's a relative term. It doesn't denote one single place. It just denotes wherever the person is when they say the word here. Now, the same is true of the term now. Question then, similar question. When is now? When is that event now? When is the moment known as now? When? Can you tell me the time that is? When does now happen? What time of day is that? Well, it also depends on context. Right, correct. So now, if I say right now, we're learning some interesting stuff about Einstein. I'm speaking at 6:30 on November the 10th, 2020. So when I speak, instead of where I speak, sets the definition of the reference of now. But if a person in 1920 was saying, hey, women have just been given the right to vote because we've approved the 12th Amendment or whatever, that speech act was in 1920. So they're not referring to 2020. They're referring to the time in the timeline when they said that. When you were born and your parents were like, wow, now we have a child, they were not referring to 2020 at that time, but their speech act was in reference to the time of history when they said that. And according to the space-time theory, there's all these temporal parts and events that are in the future also relative to our present moment. So people in 2120 who are like, let us open our history books and study the early 21st century and the global coronavirus 19 pandemic, when they speak about the word now, open our books now, this is 2120, then they're not referring to 2020, they're referring to the time that they're opening the book, which relative to their speech act is our future. So the word now does not refer to a single moment of time. It refers relatively to any moment whenever a speaker speaks. That is supposed to push back and reject a common sense idea that there's only one moment of the present, and it's right now. This means that no, the present is not really special. Any moment relative to a temporal part who uses the phrase now is relative to that temporal part now. Okay, so the last little part of Ted Sider's paper is where he just describes what are some objections that some people have to all of this. Because even though the theory of space-time is well established in physics and it's the consensus view of science, and it's got a considerable amount of empirical proof, there are many that still find it to just be too weird and counterintuitive to be correct. I think that it's not so much scientists who hold these objections, but more everyday people and philosophers. But what are some of their objections? Well, he mentions that. So some people would just throw up their hands and say, this can't be true. He's now speaking as in the voice of the so-called critic. So he says, past and future objects do not exist. The past is gone. The future is yet to be. Things do not have temporal parts at any time. The whole object is present, not just one temporal part of it. There are no future or past parts left out. And now is not like here. The present moment is special, not like the relative part of space around me when I say the word here. So some people find these conclusions that are implied by the theory to just be so strange as to be unbelievable. But let me just try and mention to you how he responds to one such objection, okay? And then we'll be done with the Ted Sider. Some people find it really weird to say that according to the space-time theory, nothing really changes. To some, that is just a bridge too far, and that means this can't be true. So, objection to space-time theory. There's more than one, but I'm just going to mention one with the time that we have. So one possible objection is, according to the theory, nothing actually ever changes, and this cannot be correct. Okay, so let's try and all think about this and grasp this together. So, according to the space-time theory, one consequence of it is that if it's true, then nothing ever does change. All the events are all out there, and so there's actually no real legitimate change. Let's see if you can understand this by giving you this example. So suppose that somebody had like really long hair, okay, and then they say, I want to change it up. I want to have a different look. Maybe it's the hot summer coming, or I don't know. So the person clips their hair and now they have a short haircut. They had long haircut at time A, and later on, time B, it's short. So a common sense thing to say, a normal reaction anyone would have would be, their appearance has changed. They've changed. They had long hair, now they have short hair. But according to the space-time theory, it's not really quite correct to say there was any change. Tell me why. why technically has there not really been any change in the difference between when they had the long hair and then not having it? Why would the theory have the consequence that that is not actually any change? Why do you think that's claimed by the theory? You say, Brooklyn, because after time it is the same. No. You're thinking, oh, it grows back? No, that's not what I mean. I'm saying, why is it not the case that there has been any change at all? I mean, they had long hair, there was long hair, and then there was short hair, but why has there not been any actual change in the entire sequence of events? Because in their timeline, they were supposed to do that anyway. Okay, yeah, well, don't think that it's just the present moment that only exists, Brooklyn and Ronald. That's the thing we got to break out of if we're going to really embrace and grasp this theory. It's not that every moment's the same either, Gary. It's that the entire timeline exists. All the moments of the entire timeline are all real. You've got to remember that. According to this theory, it's not just you sitting here watching this lecture that's a part of you that exists. It's like you in the future having kids, having grandkids, graduating. Everything that you'll ever do is already there. It's already there on the timeline. So if the theory is correct, then there's no real change because the temporal part with the long hair was always sitting there on the timeline with the long hair. And the later temporal part in the same sequence with the short hair has always been on that point in the timeline with the short hair. The whole sequence, the whole series of stages hasn't gone through any change. We just see the illusion of change by means of one temporal part being observed and then another one with a different feature being observed at another point in time. Does this make sense to you, why this is not therefore actual bona fide change? It's just different attributes of different temporal parts, which have always been there. So one of the temporal parts had the short hair, the other had the long hair, but if you look at the whole sequence and you back up from one part of it, you'd see that the entire sequence hasn't undergone any alteration or change. All the stages have set forth all the points and all the different events, and therefore what you think is change is just because you're limited to the perspective of one temporal part at a time. Okay? But in reply to this objection, here's what Ted Sider says back. He says, this objection is really not so destructive to the argument because even if it's perhaps true that there's no real change according to the space-time theory, there's still a way of thinking about change. We just have to redefine what it means. Okay, so think about this. Okay, here is a roadway. And suppose you got this guy driving along the road. Now, as he starts his journey here, the road is very smooth and well paved. So it's a very clean, smooth ride. But when he gets over later on the road, there's cracks, there's potholes, and it's just bumpy and kind of, rough ride over there. So this guy's driving, right? And let's imagine his journey, driving, smooth sailing, like, oop, now it's bumpy. You might imagine him saying this to himself or to somebody else. On my drive, the road really changed. It started off smooth, but then later on in the same road, it was really bumpy, so it changed a lot. But if you think about it, the whole road hasn't really changed. It's always had this part with a clean, smooth section. This part later on in the road has always been kind of jagged and full of potholes. There's not been any change. It's just that his observation of the different parts of the road is allowing him to observe different parts which have different features. Okay, so now, little mental gymnastics, guys. This is a metaphor. You and me are like the road itself. Every event along the timeline of our existence already exists. And what you call change, like, oh, I grew taller, or I changed my hairstyle, or I changed my outfit or something. I lost a finger, God forbid. I used to have one, now it's cut off. Suppose that happened. Well, what's really going on is that those points in your timeline with the different features were already lying there in wait for the order of your consciousness to experience them, but they haven't actually gone through any change. The entire roadway, the entire temporal sequence of events has already existed and had all of those moments contained within it. Okay, so he says, forget calling it you can still call it change, but we just have to understand that it's not like one and the same thing changing. It's different temporal parts of the same object exhibiting different features. This isn't so much change as having different attributes at different points along a timeline. but we could call it change if we want. And so he finds this to be no real difficult objection to overcome. We just have to reorient ourselves to thinking of change in a different way. Now change becomes not alteration of one object, but different properties of different temporal parts that are connected together in space-time of one object. Okay, so that's really mostly everything I wanted to say about Ted Sider. There's one more author on this topic that I did not get to yet, and that means it's because I gave you guys the day off for the election, and that gave me a little less time to present some of the material on time and everything, but I still want to cover a little bit more of the David Lewis. So on Thursday, I want to just open the meeting by quickly going over some of the main points that David Lewis discusses in his paper called The Paradoxes of Time Travel. And then we will start to transition into the next topic of the course, which is the philosophy of mind. I'm going to send off either later tonight or in the morning tomorrow the next paper prompts, and you will have 3 weeks basically to work on them because they're due Tuesday of week 15. So this is Tuesday of week 12, and by design, I wanted to give you guys close to 3 weeks to work on it. So you'll see the prompts distributed in the announcements tomorrow in the morning. I think I'll get to it when I wake up. So just look for it, and then we can talk about it when we come back on Thursday. This does not affect our class, but I'm sure you guys know that tomorrow is a school holiday for Veterans Day. So hopefully some of you get a little bit of time back to just rest and catch up on all your work. But other than that, that's just my updates for you. We've had our lesson today on Ted Sider. I'm going to give you guys your next paper prompt. As I've said a few times already, all the other midterms and essays have been graded. So if you've asked me for your grade, that's great. If you haven't, feel free to do it, and I'm happy to send you your score and any comments on the same thing. So yeah, that's about it for today. Make sure to keep reading through the book, and we'll try to catch up a little bit on Thursday, and we should be good to go as we move through the next few weeks. Okay, guys, thanks a lot. I know it's interesting material. That's why I'm proud to teach philosophy, because I think that I get to teach some of the kind of coolest things that I find interesting anyway. I don't know if everybody else does, but I appreciate your interest and your attendance, guys. So thanks again, and have a good one. I'll see you back in a few days. Or I guess it's already happening if you believe this theory. So we already did this stuff. Hopefully your grade turns out good, because I guess that already exists too. Just kidding. All right, guys, have a great one. I'm ending the Zoom meeting first, and then I'm also closing the YouTube live lecture. So here this one ends. And if you're still here, hi guys. So I'm ending this one now. By the way, quick question before you leave. Did this ever improve? Does it look better now on YouTube than it did before? Medium J, I don't know if you're still here, but if you did click the link above, you would see it in the chat. I guess nobody's able to answer my question. It's no big deal, but I just was curious to know if the buffering of the live feed improved. No takers? Nobody? Maybe one person? Going once? Going twice? Are you sure? Okay, well, not to worry. Thanks again then. I'll see you the next time. Bye-bye.